40,000 years ago, multiple kinds of humans walked the earth at once, and only one made it out alive. Homo sapiens is the last human standing, but for most of our species' history, that was never guaranteed. Neanderthals, Denisovans, Homo floresiensis, Homo luzonensis, and Homo naledi, an entire crowded family of human beings once shared this planet, and now there is only us. How does a world with several human species end up with exactly one? Was it competition, climate, bad luck, or something else entirely? The honest answer involves volcanoes, interbreeding, and a level of prehistoric drama rarely discussed. A crowded planet of humans. For most of human prehistory, Earth was never a one-species operation. Homo sapiens emerged in Africa roughly 300,000 years ago, but far from alone. Around the same time, Neanderthals thrived across Europe and Western Asia, Denisovans ranged across Eastern Asia and beyond, and Homo erectus, one of the longest surviving human species ever, still held on in parts of Asia. In Southeast Asia, the so-called Hobbits, Homo floresiensis, survived on the island of Flores for an almost absurdly long stretch of time. Homo naledi, discovered in South Africa in 2013, had a brain roughly the size of an orange, yet appears to have deliberately buried its dead in deep cave systems, a behavior usually associated with much larger-brained species. Homo heidelbergensis may have been the common ancestor of both Neanderthals and modern humans, and several more species likely remain undiscovered, known only from a single tooth or jaw fragment. At various points over the last 500,000 years, as many as 6 or 7 distinct human species may have walked the earth simultaneously, all building fires, raising children, and figuring out their next meal. These were never primitive, instinct-driven creatures. Neanderthals buried their dead, used pigments possibly for body decoration, crafted jewelry from eagle talons, controlled fire, hunted megafauna, and cared for their injured. One individual found at Shanidar Cave in Iraq lived with a withered arm, a damaged eye socket, and severe arthritis well into old age, meaning other Neanderthals had actively cared for him for years. These were thinking, feeling, socially connected people doing their best in a genuinely difficult world. Competition, climate, and interbreeding. So, what happened to them? Homo sapiens happened, though the full story is more complicated and uncomfortable than a simple takeover. When our ancestors began their major push out of Africa starting roughly 70,000 years ago, they entered territories other humans had already occupied for hundreds of thousands of years, and almost everywhere modern humans arrived, the local population began disappearing within a geologically short window. Neanderthals vanished around 40,000 years ago, shortly after Homo sapiens arrived in Europe in large numbers, and Homo floresiensis disappeared around 50,000 years ago, around the same time modern humans likely reached the region. This pattern of extinction tracking our arrival is hard to ignore, though there is no archaeological evidence of organized mass killing. The process was more mundane and, in some ways, more tragic. Homo sapiens generally had better long-range weapons, more sophisticated social networks that spread information faster, and broader trade networks reaching hundreds of kilometers away. Against that combination, existing populations stood little chance, not from stupidity, but from sheer competitive intensity, a dynamic ecologists call competitive exclusion. When two closely related species share an ecological niche, one eventually wins, and the loser does not always lose because it was weaker. But competition was not the whole story, because we also interbred with them. If you are of European or Asian descent, somewhere between 1 and 4% of your DNA is Neanderthal, and some populations in Asia carry meaningful Denisovan DNA as well. There was a period when modern humans and Neanderthals were having children together, raised in a world containing both fully Neanderthal and fully modern human communities. This was not a clean replacement of one species by another, but a messy, partial merger, where most of one population disappeared but pieces survived, embedded today in genes affecting immune systems, metabolism, and disease risk. Some Neanderthal gene variants actually proved useful, possibly helping interbred populations adapt to cold European climates faster than independent evolution would have allowed. Denisovans are stranger still, identified almost entirely through DNA rather than physical remains, just a few teeth and a single pinky bone, including people in Tibet today who carry a Denisovan gene variant helping their bodies process oxygen at high altitudes, a functioning gift from a population that vanished tens of thousands of years ago. Climate played a major role too. The period between 70,000 and 12,000 years ago brought dramatic swings, advancing ice ages, glaciers covering huge portions of the northern hemisphere, and sea levels dropping more than 100 meters at points. Large-brained, adaptable species like modern humans could migrate and innovate through this, while species with smaller, more localized populations faced potential catastrophe, especially when climate stress combined with a highly competitive new arrival. Around 74,000 years ago, a supervolcano in present-day Indonesia erupted on a scale that may have triggered a volcanic winter lasting years. Genetic evidence suggests Homo sapiens passed through a severe population bottleneck around this era, with our entire species possibly dropping to just a few thousand individuals, the ancestors of everyone alive today. Whatever role that eruption specifically played, the evidence for a near-extinction event in our own history is hard to dismiss, and if we barely survived, smaller species likely fared far worse. Island species deserve special mention. Homo floresiensis, found on Flores in Indonesia, stood roughly a meter tall with a brain about the size of a chimpanzee's, yet made stone tools and hunted pygmy elephants, surviving until at least 50,000 years ago, an example of island biogeography, where isolated large animals shrink across generations, while isolated small animals grow. Homo luzonensis, discovered more recently in the Philippines, remains even more mysterious, known from only a handful of bone fragments and teeth. What actually made the difference? The most compelling explanation for why Homo sapiens alone survived centers on behavioral modernity. Starting somewhere between 50 and 70,000 years ago, the archaeological record fills rapidly with things that barely existed before. Cave paintings, figurines, musical instruments, long-distance trade networks, and clear evidence of complex planning and symbolic thought. One leading hypothesis points to a threshold in language complexity. The moment human language became recursive, allowing sentences within sentences, hypotheticals, and the discussion of things not physically present. Once language could do that, coordination among strangers became possible. Knowledge could pass across generations with precision, and shared belief systems could bind large groups into cooperative units no small group could match. Some call this the cognitive revolution, arguably the single most important event in our species' history, more consequential than agriculture or writing, since neither would have been possible without it. The disappearance of other human species was never one single cause. It was climate instability squeezing already stressed populations, competition with a species that had stumbled onto unusually effective cognitive tools, the slow strangulation of small isolated groups, interbreeding that blurred boundaries and absorbed fragments of the vanishing into the expanding, and possibly disease layered on top of it all. Underneath everything sat a species that had found a way of organizing knowledge that compounded generation after generation, cognitively networked in a way that widened its advantage over time, like compound interest applied to survival itself. They are not entirely gone. They live on in your genome, in the shape of your immune response, in proteins helping bodies adapt to cold, in a gene variant in the Tibetan highlands tracing back to people we have almost no physical remains of. The Neanderthals were people. The Denisovans were people. The Hobbits of Flores were people. Tool-making, fire-lighting, community-raising people who lived on this planet for hundreds of thousands of years before we arrived. Perhaps the most unsettling part of this story is that Homo sapiens was never inevitable. Simply one experiment among several that happened to get the timing, tools, and networks right at the right moment. The Neanderthals looked out at their world with no reason to doubt they would always be there too. They had fire, community, and tens of thousands of years of accumulated survival knowledge, and then they were gone. If this changed how you think about human history, hit like on this video, subscribe for more deep dives into human evolution, and drop a comment with which extinct human species fascinated you the most.